Okay, npm start 5173. Okay, 5173. Okay, what I have right here is a demo I made about a year ago. It was an exercise for a job application actually. There are some things in this that are related to network, like collision detections in a wider network. But apart from that, this is a canvas animation made in HTML, and yeah, it's fairly simple thing. You actually build it in JavaScript, and you have a canvas which is like a paint program canvas. You can draw dots in certain places, and then you can erase it all, and then you can draw it all again, and that way you can make canvas animations like that. So today we're gonna take a look at how to do something like this. Maybe not exactly like this, but something fairly similar. And so we're gonna start by using Visual Studio Code. So let's start by just a new fresh project here. Yeah, so we start Visual Studio Code, we start a new terminal, and then we go to first. Let's just magnify it also so that you guys can see. Okay, so let's start by, we go to the programming directory here. This time around we're going to use Vite, which is actually a system that is used in production and for professional purposes. No, we're not just gonna use like a like JS Fiddle on the net. We're gonna use something more properly this time. So let's have a look at how to do that. Like, let's Google that. So, getting started with Vite. You first need to install npm on your system, and then you can use, let's see, yeah, this npm create Vite the latest. That's the keyword. That's the thing we want to use. Now it will create a project for us that will compile a JavaScript project to something that is minified and can be production ready for the browser. So let's name it to something dots. Okay, and select the framework. Here we could use React if we wanted to make a professional web application or something, but we just want a vanilla JavaScript project. And here we can choose between TypeScript and JavaScript, or we want JavaScript. And then we can open this project up in our Visual Studio Code. And then we go to programming, dots, select folder. So now Visual Studio Code is like centered around this folder. So whenever we create a new project like this, we usually go to package.json to see how to run this thing. And to run it, in this case, it's the dev option. That's usually for running it in develop mode, essentially. So let's open up a terminal. And in the terminal we can then type npm run Vite. No, run dev. Terminate that one because we had the other one running already. Let's terminate that and try again. So we get it on the right port for convenience. Okay. So here we have just a blank Vite project that has nothing in it. It has a basic like counter and a little bit. So we can see here the project structure. We have this folder dots. We have node modules. That's just internal data for node. That's not particularly important at this point. We have the public. We have the image. We can delete that. We have the source file. We have the counter. This is the counter code. Remove JavaScript logo type. Remove. Then we have the main. Essentially, we can remove most of it. We just want to keep that, and the style we can remove all of it also. And HTML we have a body, the script. I like to put it in the head instead. And then we have a div here. We want a canvas instead for our animation, and we can name it with an EID, and we can name this body also, and we can name it container. All right, like so. So then now let's have a look at what we have. Let's open up. Use Control-Shift-I on most browsers to get the debug container. And here we can see that we have indeed a canvas. Let's see. Maybe this is too small to read for you, but you can see the blue things flashes here. This is the HTML structure. We have a canvas that is the smaller part here, and then we have the container. It has a margin of 8 that is a kind of default for all browsers. What we want to do, the canvas want to cover the whole page. So the first thing we do then is we go to the style, and we need to style. We can look at the HTML. We need to style the HTML, the body, and the canvas here in this case. So we go to style, and we style HTML to 100%. And same for body. Now one very important thing here when we're dealing with canvases. Canvases don't like this kind of styling. So you would think that, okay, just style the canvas to set it to width and height 100% and it's fine. Yeah, we should remove that margin also. But that wouldn't work for some reason. So what we need to do is instead we need to programmatically set those values. So what we need to do is instead we need to go do the code here, and then we need to get a hold of those things. So we need first have our container, that is essentially our body. Document, get element by ID, and then we can get container, and then the same thing for Control D for duplicate the canvas. All right, so now we have the canvas, and then we want to set the values here, because this is how it works apparently. This is client width and client height. And the height. Now obviously if the container was to be resized, like if you would resize the window, this would actually have to be something more complicated, like an event listener that listens to changes and such, because this will only fire once when the page is drawn the first time and not change ever again. But let's see. Yeah, no, the canvas is still small for some reason. Okay, we didn't save it. Maybe that's the problem. Okay, so now it works. The canvas is the big blue part, but for some rounding errors and stuff, we get the scroll bars activate. So the simplest way to get rid of those is just we go to the styling again, and the body we say overflow hidden. So that's that. So now we have one single canvas that covers the entire page, essentially. So now we can start doing drawing animations and stuff. And let's see. So here we want to draw dots, right? So first make a dot class. We have a constructor, and inside the constructor we want to set X and Y. The dot has a position, and now we can use we can use math random and multiply that by the math random creates a random number between 0 and 1. And if we multiply that by the width, then it means we get a number between 0 and width. So that makes a good random position somewhere within the canvas. And we do the same for height also, and the x. And we want to draw this one, so we have create a draw function on our dot. And to draw it, we want the context. Now this is something here also. We have the canvas. How do we draw on the canvas? We do like this. Context equals get context 2D, two-dimensional context. That is like the drawing program. And on this one, what we do with the context, what we do here, you can Google these things. It's like how to draw a circle on a canvas, HTML. You will very quickly get the result. We work with so many systems, so many programming languages, and so much things all the time. A lot of the time you just copy-paste some existing code, or you copy-paste you Google it and you copy-paste it. Nowadays, a lot of people even use AI to do these things. Okay, so we begin a path, we create an arc, which is actually a kind of half circle, or like a pie chart. It's like, not, and this is in a way, it looks complicated, but essentially this is just drawing a circle on a canvas. And we set the fill style, black maybe, and we fill it. Okay, so we create a dot here. Dot equal new dot, and we take the dot and draw it and draw it on the context. Now let's see if we did everything right here. No, we did not. I know why. I think what we forgot here is that this code here wants the size. Set size to 10. Yeah, now every time we reload this page, we get the random dot somewhere on the screen. So that's the first step, just drawing something on the canvas. So the next step is, now we want to animate this. We want to erase the screen. We want to, and then we want to draw the dot, and then we want to move it a little bit, and we want to erase it again and move it and in a cycle. So that's what we're gonna do now. So how do we erase the screen? Now I'm gonna copy paste again from my previous code here. Actually, copy pasting code is a kind of art form in itself. Like how do you quickly find what to copy paste and paste it? There's the thing. And here now I want to. For some reason I want to switch colors here. So we have a white dot on a black background. It works, okay. Okay. So, and then we create a function out of this. Clear and render, okay. And now we want to call this function. Oh no, the dot should be created outside here, and then dot draw should be inside here. I just use Alt and use the arrow functions to move stuff according to my settings at least. Okay, so that's that. Now we want that one to. What you could have think here, that's like, why don't we just create a while loop, and we clear and render inside it. Brilliant, but this is not gonna work. I'm gonna show you why. If we do this, we get suddenly it starts spinning here, nothing happens. Even the debug tools doesn't work. So we crashed this one. We created an infinite loop here. It doesn't work because we give no way for the browser to render. We give no chance for it to render between our frames essentially. So what we need to do is we need to release control in between. And the easiest way to do that is to use a recursive function. So we create a render loop function here, and the render loop copy this one guy, clear and render, and then we do a trick here. We use set timeout. Set timeout render loop 0. That means after 0 milliseconds we should call render loop itself. So let's see. Now we also need to, in between the frames, we also need to add. We need to dot x. We need to move the dot. So let's create a move function here. Plus equals we just increase x and y by 1 for our move, and then we call move every clear and render after. So let's see how that works. We have closed our. It doesn't work at all. Let's see the console, see if we got. Nothing happens. Ah, yeah, it could be a good idea if we actually call the render loop. That's a good idea. Okay, so now so now when we press play, we okay, then. So now let's move it. So now when we press when we restart this page, we get a new dot that starts moving. The first thing we can do more interesting in this is we can make the dot bounce around the corners of this. So then we need acceleration. So in between the takes we need to also accelerate the dot. And now if we want to accelerate, we can't just have a fixed velocity here. So we need to have we need to have a speed, a y movement and an x movement, or x speed. You can name it many different ways. And then every time we move, we just add the x movement. Maybe speed would be a better name. I don't know. But that's it. Okay. So if this x greater than or so if this x is greater than the canvas width, or if it's smaller than the 0, then this x movement should be inverted, right? So we just take this x movement here and add a minus one to it and set it there, like so. And we do the same thing for y here. Y same thing here. If y is bigger than height, or if it's smaller than 0, then we flip the movement. Okay, so let's see if that works. Let's see. Yes. Yes. Okay. So this is basically, now we have, if some, you know the classic DVD animation that you get on many old ancient DVD players. This is basically just a bouncing sprite around that bounces around some containment. Okay, so one way we could do this a little bit more interesting also is that we add some motion blur, because every time we clear here, we just use black. But what if we use RGBA? RGBA stands for red, green, blue, and alpha. So if we say 0.1 here, so it means it's black, but it's very transparent black we fill with. So all the graphics that is in the buffer remains. So let's see what that looks like. So now we can see we have some motion blur on this one. It kind of fades behind it. So that's that. So what's the next step? Yeah, of course, to make much more balls out of it, or more dots. So instead of having just one dot here, let's create an array of dots. Dots equals, and now that we can use some trickery here to create an array of 50 undefined things. This array 50 will initialize an array with the length of 50. I've worked a long time with JavaScript, but I just recently started looking at this thing. It doesn't create an array of 50 elements that you can map and then get another array of 50 elements, but somehow it works and use the spread operator to insert in a constructed array here, and then you get an array of 50 elements. So to make a long story short, this thing just creates an array that is 50 long with all undefined values. And we just map it, and we don't even care about what's already in this array, because we're gonna, for each position, we just want to create a new dot. What this all does is create an array of dots, essentially. And we go to here. Now we don't have the dot anymore. It's already kind of seeing that. So for a dot of, so now we create a loop here, and inside here we do the same with each, or we draw and move and accelerate them. Let's see how that works. Yes, so we can remove the. Yeah, we removed. You see, the canvas doesn't rescale now because we just do it on initialization. But if we reload the page now, we have a new canvas size. The demo I showed in the beginning had a lot of like network lines between the dots also, but I'm not gonna show that today. That's maybe in another video, so not meant to make this video too long. What we got here already is like the basic ideas of how you draw and update a canvas, so you can animate stuff and make video games. There are also people who use this to make artwork, essentially generative artwork, and it can look kind of beautiful. But before we stop, I'm gonna elaborate a little bit more on the things we did here, the render loop, because this is a very simplistic way of doing the render loop, and sometimes you want to have more control. You want to maybe want to wait a little bit. You don't want too high FPS in some situations, frames per second. So let's do this render loop in a little bit different way here. Let's comment it out first, by the way, and make an alternative implementation. Let's create an async function, and what that means is that now we have the possibility to await things in here. And that means that we can now use a normal while loop. And what we do in the while loop essentially is the same, clear and render. Let's call clear and render there. And now we want to await for something here. And what we await for is always a promise, something that is promised to happen in the future. And we can also use the timeout here to say that, okay, we wait for something that's going to happen in 0 seconds. And that will also trigger, like, we can release control to other processes and don't stall the system. We can create a promise here. A promise is essentially just an object that takes a function that has a resolve and then a. Now we can use this set timeout again. And we can resolve within 0 milliseconds. So now let's see if this works. This should basically mean that we release control and let it render. Okay, so and this reloads automatically, but since we're in the dev mode, that's the nice thing about using the dev mode like this. Whenever you change the code, the whatever you're running updates automatically, and it still works. So our async function also works, but we can make this a little bit nicer before we end here. We can take this one here and call it some. No, that release control. And we can call it. So good code should always be very self-explanatory. Now it complains here and that's because we forgot to return. We need to return the new promise here. Here we can have a, instead of just 0, we can have a wait time in milliseconds, and that one can be default value 0, so you don't have to set it. And this can be useful in other things if you want to have a gaming loop here that you clear and render and you model physics and stuff, and maybe at the end you want to wait a certain you might want to wait to not get a too high frames per second. If you have a too high frames per second, you can run into issues like there's too small movements of your sprites and your things in the world, so you get into rounding errors and stuff. So there might be reasons why you want to wait. You want to render something, wait, and then see how long it took. And if you're going too fast, you might want to wait a little bit more to get lower the frames per second a little bit. So this is like a more mature way of doing the rendering loop than this first just recursive stuff we did. Next time we're going to look at how to do the lines between the dots. So if you're looking at this and if you have questions and ideas of what I should focus on in these videos, please leave us a comment or send me an email, and maybe I can do something about it. So yeah, that's it for today. Leave a like and subscribe. See you.